Hello, in this lesson, we're going to talk about the change of base formula, change of base formula for logarithm, change of base formula. We have learned all of these properties and practiced much, right? For change of base formula, this is a change of base formula, okay? Suppose we have an old base, okay? Of course, all the base has to satisfy that condition, okay? All the bases, okay? So all the base has to be greater than 0, any base, and not equals to 1, okay? Regardless, it's old or new. So suppose we have an old base, right? On a omega, and we want to change it to a new base, okay? This is the formula that you will have to remember, but it's fairly easy to remember. So it's a log base of the new base, right? The new base is also going to be less, not equals to 1, larger than 0. And on omega, divided by log base of the new, because the entire old base will be converted to new base, but this time it's going to be on the old. Okay, so let me put this as lowercase. Okay, so the old base can be transferred to new base, and this is the change of base formula. Okay, this is the change of base formula. You can see that change of base formula may be confused with the quotient rule, right? With the quotient rule. But you can see the quotient rule, okay, the quotient rule is they are all the same base. They're all the same base, okay? Remember the mistake we made, right? In the common mistake section, right? So this is the correct one. But there's a common mistake. That common mistake is taking something like this equals to log base B of capital A divided by log base B of capital B. Okay, this is totally wrong. This is a false. But you can see these three forms can be very confusing, right? If you're not clear about which is which, right? And this one is neither the quotient rule nor the change of base. But this is a very common mistake, okay? This is a common mistake. So don't make that mistake. We have talked about it. Wait, what did I do? Okay, so let me rewrite this. So let's log base B, log base B. So when they are putting together side by side, you can see that this is a mistake. Okay, this is actually a common mistake. This is the common mistake, right? This is the common mistake. So be sure you understand that, right? When they're put side by side, this is correct. This is a quotient rule, and this is a change of base formula. So we have lots of mistakes. We have lots of mistakes that confusing and confusing these three. Okay, we have talked about why this is false in the common mistake lesson. Okay, and today we're going to just work with change of base formula. We're going to work with change of base formula and be aware of these mistakes as we start out with the examples. Okay, so here we go. We're going to practice on using change of base formula. When do we need to use change of base, right? So first, let's explain change of base. Okay, let's first explain change of base. If you look at your calculator, right, why change of base? Wait, let me put it this way. Right. Why change your base? Why change your base, right? If you look at your calculator or any computing apparatus, right? Calculator, your cell phone, well, if they have, smartphones certainly have log. But in most of the cases, you will see the button of log, which is a common log, right? On calculator, right? On calculators. The log button or the ln button. That's about all. Okay, so we have these buttons. Okay, we don't have buttons like logs usually, right? There's no these buttons. None of these. Okay, and these are log base 2, right? And we don't have log base 3. We don't have these buttons, etc., etc. We don't have log base, log base 5, etc., etc. So you can just name any base which is larger than 0, not equals to 1, right? We usually don't see these buttons. If you do, you probably have to pay a little bit more for that calculator. Most commonly, we have the common log. For those more advanced, for those the calculator with ln, you probably have to pay like a little bit more money for it, right? Why? It's because you have one log button of any base, you just need one. That will be sufficient because every other base can be converted to common log. If you have common log, that's more than enough. That is sufficient for you to handle any log situation. If you have the additional natural log, great, right? You have more, but you really just need one. So you know you're paying extra for something you don't really need, okay? So that's the point. So now, because of this formula, right? Suppose you have a calculator. Okay, only suppose there's a calculator, right? With only common log, which is base 2, which is base 10, right? No problem. If you have a situation of log base 2, you can follow this formula. Okay, you can follow this formula, right? So now your old base was 2, and you want to convert it to base common log, right? So what you do that you would just, your new is going to be the 10, right? So you're going to change your base to be base 10. Base 10. And the old, of course, is 2. And you know that by default, we just write log, right? Log means log 10, log base 10. And there you go. So you can convert base 2 to common log. Okay, that's why you can convert any base to common log. You only need one button. But, right, some calculator has ln. Well, then you have 2 options, right? You can convert log base 2 to ln and ln. There you go. You got it, right? And so that's how we convert, that's how we can use change of base formula. So what are the practical uses? So let's look at some examples of some of the practical uses, right? Some of the questions we've done before can actually be resolved by using logarithm. We can use logarithm to resolve those issues, right? For example, we did this question before. Okay, so example number 1, right? I remember we did this one in the previous lesson. We have a log base 2. I'm sorry, we have log base 4 and square root of 2. Right? We work hard on the power. We work hard on the power. And so let me bring these stuff with us. Okay, let us bring these stuff with us. So in case we need it, right? So here we go. Okay. All right. Suppose we work on this example. Instead of manipulating the power, right? Manipulating, converting root 2 to 4 to a certain power, which we did before, we can use change of base to solve that issue very easily, right? So suppose we're going to change to new base, and the new base is going to be 2. So the new base is going to be 2. New base is going to be 2. Okay, so let me make the fonts just a little bit larger so you can see better. Suppose I'm going to convert to base 2. According to the formula, the old base is 4. So the old base 4 is going to go here. And the omega is root 2. There you go. Right, so we use change of base formula. We can actually make it much easier for ourselves, but you just need to make sure you write it down properly. Okay, you need to write it down. Be watchful of these mistakes. Okay, these are the correct ones, right? Do not do that. Okay, do not do that. Okay, all right. So here we go. And the top, what do we have on the top? The top is, let's write it one more time, right? It's log base square root 2 is 2 to the power of half. 2 to the power of half. Okay, so let me make the fonts even larger so you can see even better. And the bottom is already 2, right? So the top is equals to half. And 1/2 divided by 2, that's the half of half is a quarter. Half of half is a quarter. Right, so in this case, if you recall this example we did in last example, it's much easier, right? So let's try another one. Let's try another one. And this one I will, so it's a log base 9 of square root of 3. Square root of 3. Okay, so what do we get? Right, change of base formula. Change of base formula, right? Of course, change of base formula is not the only way, but in this case, I think using change of base formula will make it so much easier. Make it so much easier. So the base we're going to change to, okay, the base we're going to change to is going to be base 3. Okay, so we're going to change log base 3. Okay, and here's the formula, right? So you see that formula right next to it, right here. The old base is 9. Omega is this piece, right? Omega is this piece. So you can just put the formula right next to you. Right, the old base is 9. So 9 is going here. And we decided the new base is going to be 3. So new base is 3. You get to decide the new base, okay? And omega is square root of 3. So omega is square root of 3. I just copy and paste. And here we go, right? So the next expression is going to be equals to, so just work it out on scratch, on scratch paper or whatever, right? Using the formula every time before you get really good at it, right? So next one is just similar to the previous one, and the bottom is 2 because 9 is 3 squared and the top is half. So in the end, we get a quarter, half of a quarter, half of half is a quarter. So that's change of base formula right there. And some of the examples we did before, it can be used to do this, right? Let's look at this one. Now, that's example number 2 and example number 3. Okay, we have a log base 9 and then 27, right? We can manipulate 9 to be, we can manipulate 27 to be expressed in terms of 9 to a certain power. So we can try to do this. Well, in this case, if we try to express 27, right, which we can, it's a little it's a little work because our goal will be writing 27 into 9 to a certain power. It can be done. It can be done. Okay. But the question is, it would be much easier. It would be much easier if we do it by change of base formula. Okay. So I will show you how to do the change of base formula because this is about how to do change of base formula. And then this comes to when do we use change of base formula, right? We talk about that when you actually need a calculation, you need a numerical value, you do, and from your calculator, you will use the change of base formula. Typically change to common log or natural log. Either one will be sufficient. For academic reason, right? You're taking these classes and you're trying to fulfill your academic requirement. The typical typical academic questions, when you see these two numbers, right? The base and omega, they have some kind of common base, right? And that common base now is 3. Okay. Say 9 can be written as 3 squared, 27 can be written as 3 to the power 3. So this is the time that, in my opinion, right, is the time you can think of using change of base. It will make the calculation a little bit easier. Okay, so the old base is 9. Okay, so by this time you will get the denominator equals to 2 and the numerator equals to 3. So that makes it pretty easy to do. And however, right, if you don't do this, then you need to figure out how 27 is expressed to 9 to a certain power. And of course, now we already know the answer, right? We know the answer. So you can go that way. So I will leave that for you if you want to explore that way. And I'm just going to focus on using the change of base formula. Okay, so let's do another one. Let's do another one. And they're all very similar, right? For example, this next one, example number 4, and you have a log base of b squared, okay, and b to raised to the power 3, right? So in this case, it will be most convenient to use change of base formula, okay, provided that b, right, b is greater than 0, not equals to 1. Okay, so we always have these assumptions. So by default, you know, when we're dealing with logarithm, all the bases is larger than 0, not equals to 1. Just don't forget that. So in this case, if we will use change of base formula, and we're going to use a new base, which is a log base B for top and bottom, log base B. Okay, and then omega, of course, is B to the power 3. And the old base was B squared. So you put it at the old base. And then the simplification will be pretty straightforward. And the top is 3 and the bottom is 2. Okay. Let's do a few more. Okay, example number 5. And here we have log base square root of B, okay? And omega is cubic root of B, right? So what do we get now? If we do the change of base, and our new base will be log base B, right? For both top and bottom. So by this time, I assume you guys are pretty good at it, the formula already. So at the omega place, right? The omega, right? The old base, omega. So omega is going to be on the top. The old base is going to be at the bottom. And the rest is, we're just going to be dealing with fractions, that's all. The top is going to be 1/3. And the bottom is going to be 1/2, right? Because root 3 of B is B to the power 1/3. Okay, so if you, just in case you're not sure about it, so this piece is B to the power of 1/3. And that one is B to the power of 1/2. Okay. And then we come to reduce the fraction, and the common denominator, of course, is 6. The common denominator is 6. So we multiply 6 on top and bottom. Principle number 1 applies. And we simplify the top and bottom, and we will get, on the top is going to be 2. The bottom is 3. That's it, right? Let's do one more. Okay, I think you probably already get the hang of it. Okay, this will be the last one. Okay, in this set of examples. So log base e to the power of 3. Okay, and at omega place is e to the power of 5. Right? Apparently, in this case, we will choose to use natural log as the e as our new base, right? So we have ln, right? The old base is e to the power of 3, so that goes under. The new base is on the top. You just need to make sure you write it down properly after you understand how to use these properties, okay? Really write it down properly. So you must learn to write it down. And at first you're gonna be just, follow the examples, and soon enough you have the habit of writing down correctly. So that's it. Okay, so in this part of the example, we have covered the change of base formula and its application. In the other situation, right, for numerical calculation, we're just going to do like a couple examples, right? For numerical, for using calculator. for using calculator for logarithm, okay? For logarithm, what do you do? For using logarithm button, right? What do you do? So suppose you have a logarithm button and you really need a numerical value, okay? And suppose we have a log base 3 of 5. And you need a numerical value, okay? For this course, you never have to do that, okay? But I'm going to show you how to do it. So suppose you have the log button. What you need to do is you just, use a change of base formula. Your new base is going to be common log, right? Because you only have common log, available to you, and the oldest base is 3, and then you're going to be using common log and 5. So what you need to do is that you are going to calculate the numerator. So first, right? So first, you're going to do the numerator. So you press your button, do that. You get a numerical value. And second, the first and second can be done at the same time, okay? First and second, or second first, right? And you get the numerical value, okay? Or you can, let me put it this way. You do first and second at the same time, okay? Separately. Secondly, you're going to take the numerator, right? Wait. You're going to take this piece and divide the numerator by the denominator. So that's the order of operation. Okay, that's the order of operation. So that's how you do it. Okay, and you can do this for any logarithm, right? And for the natural log, it's similar. For natural log, it's very similar. Okay, but since most calculator doesn't have these functions, I'm just going to cover this using that option. Suppose you have a natural log as your button, right? You have that button for natural log. Okay, and the idea is the same. So for the same situation, right? You're gonna do ln 5, right? Let's see what ln 5 gave us. ln 5. Whoops. So ln 5 and ln 3. ln 3, right? And then you divide these two numbers. Oh, they actually happen to be the same. I wonder what your calculator will give it to you. Okay, but that's the order of operation. That's the order of operation. Okay. This software I'm using at this point, actually, I have a little doubt whether they're correct. Okay, so use your calculator properly, because this software I'm using should have common log and natural log, but because they're the same, I'm a little doubtful if the software is done correctly. Okay, I will double check, but you will get the same answer. You should get the same answer for sure. Okay. As a course, I'm not going to test you using these calculator part. So you just have to read your calculator menu to do it right. Okay. So for further questions, you're welcome to ask, and I'll be more than happy to discuss these with you. Okay. Thank you for watching. Until next time.